What is PQ? It is a distance formula x2 minus x1 whole squared plus y2 minus y1 whole squared. Here it is a three-dimensional. And then 180 minus theta falls to which quadrant? It falls to the second quadrant. In second quadrant, cos is negative. Similarly, can you guess for along the y-axis? Along the y-axis, simple. Along y-axis, what? Alpha, beta and gamma. Along y-axis, x and z. Y-axis is perpendicular. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So dear students, in today's session we are going to learn chapter number 11 called Three-Dimensional Geometry from your second PUC NCERT textbook. And here we are going to have session number 1, and the topics we are going to study in this chapter is nothing but these are all very important years, and then also in this chapter they are going to ask 1 marker 1 question, 2 marker 1 question, 3 marker 1 question and 5 marker 1 question. Totally 11 marks they are going to ask from this chapter. So the 5 marks will be a derivation. Definitely they are going to ask. 3 marker and 2 marker will be a problems, and 1 marker also. Understood? Now we'll be moving on to the direction cosines and direction ratios of a line joining 2 points. This also we are going to study the starting and discuss about the equations of a line. This is very important. And planes in space under different conditions. And then angle between 2 lines, 2 planes, a line and a plane. So what is the angle between that? And then shortest distance between 2 skew lines and distance of a point from a plane. So these are all the things we are going to study under this chapter, dears. Now we'll be moving on to what are all the direction cosines and the direction ratios. And here I have taken a diagram like this. See, this is going to be known as the y-axis, x-axis and the z-axis. And then I am going to take a line which is along the x-axis. Okay, and then I am going to draw a three-dimensional which is nothing but from the z-axis to a line L of the x-axis and perpendicular to the line y. And this diagram in that form an angle of, see, x-axis will be forming an angle of alpha and y-axis will be forming an angle of beta and z-axis will be forming an angle of gamma. Okay, that's I have taken that. And then this is nothing but OP is a point on that line and OP is nothing but R, that is a distance. So same explanation I have taken here. If you want, I can, in a direction line L, this is a line L, passing through the origin makes an angle of alpha, beta and then gamma respectively, called as direction angles. What it is called? Direction angles. Then cosine of these angles, namely, so angles will be alpha, beta, gamma. Cosine of that angles will be what? Cos alpha, cos beta, cos gamma. That's what I have taken. Cos alpha, cos beta and then cos gamma. What are that known as? That are known as direction cosines. So, remember this, direction angles are alpha, beta and gamma along the x and y and z axis, and then cosine of that angle is cos alpha, cos beta, cos gamma, called as direction cosines of that directed line L. Okay? Now, we'll be moving on to any 3 numbers which are proportional to direction cosines of a line are called direction ratios, which are proportional to that angles is going to be known as what? Direction ratios. And here direction ratios, I am going to take it as A, B, C. Okay. So here if L, M, N or A, B, C, L, M, N are the direction cosines. That means here I have taken L is equal to cos alpha, M is equals to cos beta, and then N is equals to cos gamma. So these are all the direction cosines. And what will be the direction ratios? Direction ratios here A, B and then C. Okay. Then we are going to write it as A will be is equals to lambda L, B will be is equals to lambda M and then C will be is equals to lambda N. For any non-zero, lambda belongs to the real number. That means lambda is a real number here. Okay, non-zero real number. It cannot be a 0. So this is what the explanation, and here I have taken let A, B, C be the direction ratios of a line L and LMN be the direction cosines that of the line, then L by A is equals to M by B is equals to N by C is equals to K, where K is nothing but some constant I have taken, and here you can cross multiply. L is equals to AK, C here, and then similarly M is equal to BK, and then N is equals to CK. So therefore here we know that L plus M plus N squared, that is L squared plus M squared plus N squared will be is equals to 1. That is direction cosines of an angle will be is equals to 1. Okay. So this also you have to keep it in mind. So here if you have taken L squared plus M squared, you can have it as by substituting the value of L is AK, so which will become AK squared, that is A squared K squared, plus this is BK squared, that is B squared K squared, plus this is CK squared, which is C squared K squared is equals to 1, and then A squared you can take K squared common, which is nothing but A squared plus B squared plus C squared is equals to 1, or you can write it as A squared plus B squared plus C squared divided by 1, that is 1 divided by that is equals to K squared. You can shift A squared plus B squared plus C squared to the right hand side. Otherwise, K will be is equals to plus or minus under the root of 1 divided by A squared plus B squared plus C squared. Under the root 1 is 1 only, divided by root of A squared plus B squared plus C squared. So this is what you are going to substitute in the value of K. So therefore, when the direction ratios are given, how to calculate the direction cosines? Here it is. You are going to take the value of K, which is nothing but, so plus or minus 1 divided by square root of A squared plus B squared plus C squared along with A, because K gives you that value. Similarly, M is equal to B divided by square root of A squared plus B squared plus C squared. Similarly, C divided by square root of A squared plus B squared plus C squared along with the minus symbol. Understood? So this is very important, yes. Now we'll be moving on to the next relation between the direction cosines of a line. So what is a line I have taken here? Here a line I have taken, you can observe that along the x-axis I have taken a line, and then so here I have taken let P of x comma y comma z be any point on that line. Okay. So that line will be having a parallel to another line which is nothing but RS. So this line is parallel to the line. This is what? AP. Understood? And making an angle what? Alpha. That's what I have taken in an explanation. Consider a line RS. So this is a line RS with the direction cosines L, M and N. Through the origin, draw a parallel line. This one. Through origin, draw a parallel line to the given line and take a point of any point, anywhere you can take P of x comma y comma z on this line. From P, so here, from P, okay, you are going to join the points, draw a perpendicular to a PAC. You can observe, this is what the perpendicular I have drawn from P to A, okay, and then on which axis? On the x-axis, and then you can observe OP will be is equals to what? So this distance here, this distance will be is equals to R. Understood? From O to P, the distance you can take it as R. Now here, let OP is equals to R. Similarly, to show this diagram, how the cos alpha, because cosines we are going to measure, isn't it? I have taken like this here. You can observe here. So this, if you make it as ulta, it will be like this. So O, P and then A, you are going to get it as here. OP is nothing but the distance R here. Alpha, which is a cos alpha, you can take it as what is cos alpha? Adjacent divided by hypotenuse. Adjacent is nothing but OA, hypotenuse is nothing but OP. That's what I have taken here. OA divided by OP, and OA, since it is along the x-axis, OA will become x, and OP you know already it is a distance R. So cos alpha is equals to x by R. Otherwise we are going to write it as, see, x will be is equals to, which implies x will be is equals to cos alpha into R. So what is cos alpha? Cos alpha, we know that L, that's what I have taken, x will be is equals to LR. Similarly, y will be is equals to, if you take the line along the y-axis, see the line along the y-axis and parallel to the y-axis. So therefore, y will be is equals to cos beta into r. What is cos beta, dears? M. So y is equals to mr. Similarly, along the z-axis if you take, so then z will be is equals to cos gamma into r. What is cos gamma? Cos gamma is nothing but nr. Okay. So this is what you are going to have it as. I hope you understood this one also. Now here, let me take it as what is L plus m plus n squared. So here, let me take x is equals to LR and y is equals to mr and z is equals to nr. So here, if you take it as x squared plus y squared plus z squared, let us do this one, x squared plus y squared plus z squared. So which happens here, x squared is nothing but L squared r squared plus y squared is nothing but m squared r squared plus z squared is nothing but n squared r squared. So therefore you can have, which implies r squared you can take common, which is L squared plus m squared plus n squared. So you know already L squared plus m squared plus n squared is equals to 1. So you can write it as, which implies therefore x squared plus y squared plus z squared is equal to r squared into 1. 1 is nothing but L squared plus m squared plus n squared. Otherwise we can write it as x squared plus y squared plus z squared is equals to r squared. This is a standard. You can take it as. Understood? So this is what you are going to have. Right? So therefore, how to prove the last result, L squared plus m squared plus n squared is equals to 1. That is, you know already x squared plus y squared plus z squared is nothing but r squared into L squared plus m squared plus n squared. Therefore, we are writing r squared into L squared plus m squared plus n squared is equals to what? R squared. Divide throughout by r squared, of shifting r squared to that side, you are going to get L squared plus m squared plus n squared is equals to 1. This is what the case we have used as in the last case to have what are all the direction cosines along the direction ratios. Okay. That's it. Yes. Now, we'll be moving on to the next concept, which is also very important. Direction cosines of a line passing through 2 points. So, here I have taken the direction cosines of a line passing through the given 2 points. I am taking P of x1, y1, z1 and then Q of x2, y2, z2. So, here I have taken, let this is be the x-axis, y-axis and then z-axis. So here we have taken, let it be this x-axis and then this is y-axis and then this is z-axis. So here I have taken a line PQ and makes an angle along the z-axis. Okay, along z-axis I have taken. So this is what along the z-axis it make an angle. So if this is gamma, this is also gamma. Now you can have, this is a line P and then Q I have taken. So here what will be cos gamma. So this is P of what I have taken x1, y1, z1 and then Q of x2, y2, z2. Okay. So this is what the point I have taken makes an angle gamma along the z-axis. So what is cos gamma is this given by z2 minus z1 divided by PQ. What is PQ? PQ is nothing but distance formula. Suppose if you are having a PQ in the 2-dimensional. What is PQ? It is a distance formula x2 minus x1 whole squared plus y2 minus y1 whole squared. Here it is a 3-dimensional. 3-dimensional what it is? So PQ will be is equal to distance between x1, y1, z1 and x2, y2, z2 which is given by under the root of x2 minus x1 whole squared plus y2 minus y1 whole squared plus z2 minus z1 whole squared. So this is the PQ distance. If cos gamma is z2 minus z1 divided by PQ, therefore PQ you are going to substitute here which is given by z2 minus z1 whole over under the root of x2 minus x1 whole square, distance between the x and distance between the y coordinate and distance between the z coordinate. That's it. Understood? Similarly, what is cos beta is given by, cos beta is nothing but what? Along the y-axis, if I am going to take a line, which is y2 minus y1 divided by pq. But what is pq? pq is nothing but under the root of x2 minus x1 whole square plus y coordinate difference and then z coordinate difference. That's it. This is along the y-axis. Z coordinate difference, this is along the y-axis. Next we'll be taking as cos alpha. What is cos alpha? Which is x2 minus x1 divided by pq under the root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. And this all, it is very important to remember to solve the problems. If they have given 2 points and then if they ask you to find out the direction cosines of a line passing through the 2 points, and this is all the formula you have to remember of the direction cosines: cos alpha, cos gamma and then cos beta. Therefore, cos alpha is nothing but L, cos beta is M, cos gamma is N. Okay, when the 2 points are given, L, M, N respectively given like this. Understood? Now, we'll be moving on to solving the problem, dear students, according to the condition they have given. Here, example I have taken, if a line makes an angle 90 degree, 60 degree and 30 degree with the positive direction of x, y and z axis respectively, find its direction cosines. Here they have given an angle, therefore let alpha is equals to 90 degree and then beta is equals to 60 degree and then gamma is equals to 30 degree. What are the direction cosines? L will be is equals to, direction cosines are defined as DCs. Direction cosines are defined as DCs. Direction ratios are defined as DRs. If I write it like this, you have to consider it is a direction cosines. So which is L is equal to cos alpha, which is L is equals to cos 90 degree. You know cos 90 degree is nothing but 1, which is L equal to 1. Similarly, M is equal to cos beta, which is M will be is equal to cos 60 degree. You know, sin 30 degree is what? Sin 30 degree is root 3 by 2. So, cos 60 degree will be root 3 by 2, isn't it? So, here sin 30 degree is root 3 by 2, cos 60 degree is root 3 by 2, ulta, correct? Root 3 by 2. So, similarly, what is N is equals to, which is cos gamma. So, which is N will be is equal to cos gamma value is 30 degree. So, yes, your guessing is right. Sin, what is that? 60 degrees 1 by 2, cos 30 degrees 1 by 2, ulta, correct? So, cos 30 degrees 1 by 2. So, L and M are given by these values. That's it, yes. When they are given an angle, how to find out the direction cosines? Cos alpha, cos gamma, cos beta. Okay. So, now we'll be moving on to the next problem, dears. What they've asked. If a line makes an angle 90 degree, 135 degree, 45 degree with a positive direction of x, y and z axis respectively, find its direction cosine. Same as like before. So, let me take it as, let alpha is equals to 90 degree and beta is equals to 135 degree and gamma is equals to 45 degree. Let us find out first L. L is nothing but cos alpha, which is cos 90 degree. Just now we have found out cos 90 degree gives you the value 1. Similarly, you can have beta is equals to, which is M is equals to cos beta. But here what they have given, cos beta value is 135 degree. Dear students, how to write down 135 degree? Either 180 minus theta and or 180 minus 45 degree you can write, or 90 plus 45 you can write it as. Both also you are going to get it the same. What is that? Angle. So, same value. You can write it as cos 135 degree as cos of 180 minus 45. 180 minus 45 gives you cos 135 only. But what is 180 minus theta? Cos of 180 minus theta, in terms of 180, cos will be cos only. First, let us write down that cos 45. And then 180 minus theta falls to which quadrant? It falls to the second quadrant. In second quadrant, cos is negative. So negative 45 degrees. So what is the answer you are getting? M is equal to minus 1 by root 2. That is the answer. Otherwise, you can take it as 90 plus 45, which will be giving you the value 90 plus theta is sin theta, sin 45 degree. Cos of 90 plus theta falls in the second quadrant. Again, cos is a negative, minus sin 45 degree, which is minus 1 by root 2 only. Understood? Next, which is n is equals to cos gamma. So n will be is equal to cos 45 degree, which will be giving you n is equals to 1 divided by root 2. That's it. So L, M and N are 1, comma minus 1 by root 2, comma 1 by root 2. That's it. Understood? Now we'll be moving on to the next problem. Find the direction cosine of a line which makes equal angles with a coordinate axis. Axis is a plural form, x, y and z axis. Okay, x axis, z axis, y axis called as coordinate axis. See what they have given, makes an equal angles. So what they have given, equal angles. Equal angles you can take it as what? By data alpha will be is equals to beta will be is equals to gamma, isn't it? Now therefore you can take it as L will be is equals to, M will be is equals to, N will be is equals to cos alpha. So you know that L squared plus M squared plus N squared is equals to 1, which is cos squared alpha plus cos squared alpha plus cos squared alpha is equals to 1. So this is 3 times of cos squared alpha is equals to 1. 3 times of cos squared alpha is equals to 1. Otherwise, cos squared alpha is equals to 1 by 3, or cos alpha is equals to plus or minus root 1 is 1 divided by root 3. So, if cos alpha is equal to plus or 1 minus 1 by root 3, what is L, M and N? Same, correct, because L, M and N are equal, that is plus or minus 1 by root 3, comma plus or minus 1 by root 3, comma plus or minus 1 by root 3. So this is what you are going to have a direction cosine when the angle are equal. Understood? Okay dears, I hope you got this one. Now we'll be moving on to the next problem. Find the direction cosines of x, y and z axis. Along the x-axis, what it is? So along x-axis, you are going to get it as, along the x-axis, you are having x is equals to 0, y is equals to 90 and z is equal to, because each are perpendicular, correct, like this, see. So this is the y-axis, x-axis and the z-axis. See, this is y and this is x and this is z. See, x and y perpendicular to z, x and y. Similarly, y and z perpendicular to x. Perpendicular means 90 degree. Along the x-axis means you are going to have alpha will be is equal to 0 degree and beta will be is equals to 90 degree and gamma will be is equals to 90 degree. So what will be the direction cosines? So direction cosines is what? L will be is equal to cos alpha, which is cos 0 degree. You can have the value will be is equals to 1. Similarly, M is equal to cos 90 degree, which you can have it as 0. Similarly, N will be is equal to cos 90 degree, so which you can have it as 0. So therefore, along the y-axis, L, M and N, what it will be? L, M and N will be is equal to 1, 0, 0. Similarly, can you guess for along the y-axis? Along the y-axis, simple. Along y-axis, what? Alpha, beta and gamma. Along y-axis, x and z, y-axis is perpendicular. So you are having alpha will be is equals to 90 degree, beta will be is equal to 0 degree and then gamma will be is equal to 90 degree. Therefore, you can write it as L, M and then N will be is equal to cos 90 degree is 0, cos 0 degree is 1, cos 90 degree again it is 0, 0, 1, 0. Similarly, along z-axis, what is along z-axis? Yes, your guessing is right. Along z-axis, you are going to have LMN will be is equals to what is? LMN is cos 90 degree, which is 0, again cos 90 degree 0, again cos 0 degree 1, which is alpha, beta are 90 degree, gamma is 0 degree along the z-axis since x and y are perpendicular. That's it. They are going to ask this for 1 marker, not all, each. Along x-axis is this one. 1, 0, 0. Along y-axis is 0, 1, 0. Along the z-axis is 0, 0, 1. That's it. Okay. I hope you understood this problem also. We'll be moving on to the next one. If a line has a direction ratios 2, -1, -2, determine its direction cosines. What is the direction cosines is given by L will be is equal to plus or minus A divided by under the root of A squared plus B squared plus C squared if the direction ratios are given. And similarly, M will be is equal to plus or minus B divided by under the root of A squared plus B squared plus C squared. Similarly, N will be is equals to plus or minus C divided by under the root of A squared plus B squared plus C squared. Now, what is ABC? Direction ratios. These are all ABC. So, therefore, where ABC is equals to A is equals to 2, B is equals to -1, C is equals to -2. Let us find out under the root of that A squared plus B squared plus C squared. It is given by under the root 2 squared plus -1 whole squared plus -2 whole squared gives you the value 2 squared is 4, 1 squared is 1, 4 plus 1 is 5, 2 squared is 4, 5 plus 4 is 9. So, root 9 which is given by 3. Okay. So, therefore, what is L? L will be is equals to plus or minus A value is 2, 2 divided by root 3, root 9 which is nothing but 3. Similarly, what is M? M will be is equals to plus or minus B is what? -1 divided by what? Divided by, having 3. So, -1 by 3, isn't it? So, already you are having plus or minus 1 by 3. Similarly, you are having N will be is equals to what? 2 divided by plus or minus 2 divided by 3. So, this is what you are going to have it as plus or minus 2 by 3 minus of plus or minus 1 by 3 and then plus or minus 2 divided by 3. That is the direction cosines when the direction ratios are provided. Now, we will be moving on to the next question, dears. Find the direction cosines of a line passing through the 2 points x1, y1, z1 which is -1, 4 and -5, x2, y2, z2 which is nothing but you are having 1, 2, 3. So, therefore, what is the formula? In direction cosines, cos alpha is given by what is L will be is equal to along x2 minus x1 divided by under the root of x2 minus x1 whole squared plus y2 minus y1 whole squared plus z2 minus z1 whole squared. Let us find out first x2 minus x1 whole squared. Similarly, what is that? You are going to have M will be is equal to y2 minus y1 divided by under the root of same x2 minus x1 whole squared plus y2 minus y1 whole squared plus z2 minus z1 whole squared. Okay. Dear students, along the direction, what is that? If they have given ratios, A divided by under the root of A squared plus B squared plus C squared. If they have given passing through the 2 points, this is our direction cosines. And then N will be is equal to Z2 minus Z1 divided by under the root of X2 minus X1 whole squared plus Y2 minus Y1 whole squared and then plus Z2 minus Z1 whole squared. Please remember these all formulas. So, next let us calculate first what is under the root of x2 minus x1 whole square. It is easier to substitute, right? y2 minus y1 whole square plus z2 minus z1 whole square. Correct now? So, now what is x2 minus x1? You can calculate here only. See, x2 minus x1, 1 minus of minus 2 which is 3. So, let us calculate like that only. 1 minus of minus 1 which is 3 square again plus y2 minus y1, 2 minus 4, 2 minus 4 is minus 2. So, minus 2 whole squared plus next you are having z2 minus z1, 3 minus of minus 5, 3 minus of minus 5 is 3 plus 5, 3 plus 5 is 8. So, which is 8 squared. So, if you calculate this under the root 9 plus 4 plus 64. So, you are going to get 9 plus 4 which is 13, 13 plus 64, 77. So, under the root of 77 is your distance of A and B. If you are taken this is A point, this is a B point. Okay. AB, you can write it as, so therefore you can substitute L will be is equals to x2 minus x1, which is 1 minus of minus 2, which is 3, divided by under the root 77, and M will be is equal to y2 minus y1, which is 2 minus 4, minus 2 divided by under the root 77. Similarly, N will be is equals to Z2 minus Z1, 3 minus of minus 5, which is nothing but 8 divided by under the root 77. And this is your L, M and N. So, LMN is equals to 3 divided by root 77, comma, minus 2 divided by root 77, comma, 8 divided by root 77. So, that's it. I hope you understood all the problems which you have solved along the direction cosines ds. So what we have solved here, we have derived the formula of the direction cosines, and also we know that what are all the direction cosines when the angle is given, which is cos alpha, cos beta and cos gamma, LM, and then what are all the direction cosines whenever direction ratios are given, that is plus or minus a divided by under the root of a squared plus b squared plus c squared. Similarly for b divided by, which is m, and then similarly for plus or minus c divided by square root of a squared plus b squared plus c squared for n. That is the direction cosines along the direction ratios. The last is nothing but what we have studied. We have gone through the direction cosines whenever equal angles is given. Similarly, direction cosines along the x-axis, along the y-axis, along the z-axis, and at last direction cosines when the 2 points are given. Understood? So these are all very important. You have to know, and very easier chapter, dear students. In the next class, we'll be moving on to the derivations and some more problems based on this concept. So until then, dear students, keep watching. Thank you. Have a nice day.